Today we're going to talk about multiplying numbers with decimals. So I had you write down this procedure. Multiplication with decimals is a lot like multiplying numbers without decimals, except there's two extra steps at the end. Okay? So let's say that we're starting with a problem like 1 35/100 times 6 4/10. So write down this example. 1 35/100 times 6 4/10. Write down in pen. If you don't have, if your pencil isn't working, write it down in pen. Then, this first step is just to multiply the numbers as you normally would. Treat them as just a regular 3-digit number times a 2-digit number. So, I have to rewrite it. Write it with the decimal points though. 1 35/100 times 6 4/10. Now, is there something that you notice about writing it? Did I line up the decimal points when I wrote it? No. You have to line up the decimal points when you multiply. No, it's only when you add and subtract. Because the place values at this point are not important. We're just going to multiply each digit like you would. So follow along as I multiply this, okay? I'll take questions at the end, okay? So, start by multiplying each digit. Just ignore the decimal points and multiply each digit. 4 times 5 is 20. 4 times 3 is 12, plus 2 is 14. And 4 times 1 is 4, plus 1 is 5. Now notice I'm not putting the decimal point in at all. I'm just ignoring the decimal point. It's just like it says in your procedure. Ignore the decimal points to start with. When you're multiplying, ignore them. We're going to deal with them later. Now you go on to the next digit. So since we've already multiplied one digit, we still have to put a 0 in to hold the next place. And some of you I know like to erase, which is a pretty good idea, to erase these numbers because we're not going to be using them again. Now we're going to multiply the 6 by every number. 6 times 5 is 30, so 3 and 0 go like that. 6 times 3 is 18, plus 3 is 21. Put the numbers in the right place. And 6 times 1 is 6, plus 2 is 8. So the 8 goes outside of the 5. Then we add up these digits. 0, 4, 6, and 8. Now we go on to step 3. Once you've written the answer, now you go on to step 3. And step 3 is to go back to the original problem and count how many places there are in the entire problem that are behind decimal points. So in the first number there's 2 places, so we'll write 2PL, stands for 2 places. And in the second number there's 1 place, 1PL. Does everybody see that? The 3 and the 5, that is 2. And the 4 is 1. So there's 3 numbers to the right of decimal points in the problem. Does everybody understand that? That's where that 3 places comes. 3 PLs, 3 places. So what you do then is, starting from the right of your answer, you move the decimal point into your answer 3 places. And that's where the decimal point goes. So the actual answer is 8 64 hundredths. 8 64 hundredths. Now, what happened to the 0 at the end? Why didn't I write 6, 8, 0.640. What happened to the 0? Is this right? Amelia?
0, like after the numbers, without any numbers after.
Right, it doesn't have any value. Yeah. Zeros to the right of the decimal point when there's no other digits other than zeros don't have any value, so I don't need to write those. In fact, you shouldn't write those. You should drop those zeros when they don't have any value, okay? Yes? No, I just said don't write them. The only time you should write them is if they have a purpose. For example, if you were writing dollars and cents, then you should have 2 decimal places in your answer, because that's how you write dollars and cents. Then it has a purpose. But in this case, 8 64/100 is the simplified answer. Okay? So that's what you should do. Alright? Is just drop that 0. Okay? Now, turn to page 54 in your book. Page 54. Start with number 3. Number 3 says, stop talking. Oh, I'm sorry. I changed to 53. Page 53. I was off by 1. Page 53, number 3. It says copy the problem, place the decimal point in the product. So it gives you the problem and then the digits in the answer. How could you use estimation to figure out where the decimal point should go? Where should the decimal point go using estimation? Calvin? After the 1, why? Okay, so using what we learned, there's only 1 digit that's behind a decimal point. So if we move it in 1 place, that's where it should go. Yep. There's another reason, using estimation, we can figure out where to put the decimal point. Arthur?
Well, you can just do 6 times 8, and that's 48, and then that's around 51, so...
Yep. Keep going. Yep, that's exactly right. That's 48 is approximately, that squiggly equal sign stands for approximately 51 2/10. Okay? So we can check our answer using estimation. Shania. Yes, thank you for asking. Yep, this is what I want you to write down. Both of these things. Okay? Yes. 6 times 8. 6 times 8 is 48. Well, because in estimation, you don't need to multiply the 4. We're using estimation to figure out where we put the decimal point. No, yeah, you were going up to 7 at this point. How about the next one, number 4? 3 1/10 times 9 1/10. Then the digits are 2821. Where would we put the decimal point? Thomas?
In between the 8 and the 2.
Why?
Not the first two, the third two.
Okay,
Because if you just got rid of the ones at the end and you did 9 times 3, that would equal 27.
okay, so 9 times 3 is 27, and that's close to 28. Why else would we put it there? David?
Because there's only one number behind the point, decimal point.
There's one here, so one place here, and one place here, which equals 2 places. So we would move it 2 places in.
Oh, so you count both places.
Yes, you count both places. There's 2 numbers, 2 places behind the decimal point in the problem. Okay? Now, here's what I want you to do for tomorrow. Start with number 7. And do 7 through 19 all. 7 through 19
Okay.
all.
Thank you, Mr. Monkey. You are doing us to talk math.
7, yes, yep,
Do we have
7
to
through
take our
19
strong
all.
first?